Hi, Professor Baldwin here, and today we're going to learn about the parabola. So on the top right here, we have a picture of a very generic parabola. A parabola is like a quadratic, right? It has that U shape. Notice that the parabola here has this horizontal line called a directrix. It has an axis of symmetry, the vertical line that cuts the parabola in half, and it has a point called the focus. Now, the focus and the directrix have this unique relationship such that any point on your parabola is going to be equal distance from that focus and from the directrix. So look at this first example. This is a standard equation with a vertex of 0, 0, the origin, and it has a vertical axis of symmetry. This parabola is opening upward, and because it's opening upward, we know that the P is positive. If it opened downward, P would be negative. And because it's opening up or down, we know that it's an x squared parabola. So it's x squared equals. Now, looking at that graph, you see that the distance from the focus to this point xy is exactly equal to the distance from that point to the directrix. That's that relationship I was telling you about, that the distance between any point on that parabola and the focus is exactly equal to the distance from that point down to the directrix. So when we have a parabola equation, we're going to use these values to help us graph that parabola. We'll also use these values to help us come up with the equation for a parabola. Okay, so we went over this first example, vertex 0, 0, and it's an x squared, so it'll open up or down. The next possibility is keeping the vertex again at 0, 0, the origin, but if the parabola opens to the right or to the left, then you have a y squared parabola. Now, what if either of these shifts? It shifts up or down or left or right. Well, a shift is going to give you a different equation for the parabola because that vertex is now a point other than the origin. So, still notice that the left side of this first equation is an x squared, right? If you were to FOIL this x minus h squared, you're going to get an x squared equation, and that gives you a parabola that opens up or down. And looking at that second, you're going to get a y squared, which will be a parabola opening to the right or to the left. And then your vertex is your h and your k, and we have the equations for the directrix, the focus, your axis of symmetry, etc. Lots of information to be able to quickly reference and identify what type of parabola you have. Now, let's look at a couple of examples. This first example, we have a y squared. So we know that this parabola is going to open left or right. And because we have a negative here on the right-hand side, we know that our parabola is going to open left. So, quick sketch, it's going to look something like this. We need to find the vertex. Well, on the left, it's strictly y squared. So we know that our vertex is going to be the origin or the point 0, 0. Next, we can find the focus. And the focus is the point P0. Now, recall that the standard form for a y squared equals parabola is y squared equals 4px. So 4 times p is the value in front of our x. Well, for us, that 4 times p is equal to -6. If we divide by 4, we discover that P equals -6/4 or -3/2, which means our focus then is the point -3/2, 0. And lastly, we have the directrix. The directrix is going to be the equation x equals -p. And we found our p. So x equals negative, our p is a -3/2. So that simplifies to x equals 3/2. Now we can put each of these onto a graph to help us in graphing our parabola. We know that the vertex is 0, 0. Our focus is -3/2, 0. So that's -1.5, 0. And our directrix is going to be the line x equals 3/2, or this line. Now there's a couple of ways that we can go about finishing the graph of our parabola. We can use these distances to help us find points, or we can try to use the equation to help us find a point. I'm going to use the equation. So knowing that y squared equals -6x, I'm going to have to take the square root in order to get the y. So y is going to be equal to plus or minus the square root of -6 times x. So I want something that's going to be easy to take the square root of. So what if x is -6? Well, if x is -6, then I would have y equals plus or minus the square root of -6 times -6, or plus or minus 6, which gives us the point -6, 6, and -6, -6. So here is that parabola. For the next example, we're going to find the vertex, the focus, and the directrix, and then we're going to actually look at how to graph it using our graphing calculator. Okay, with this second example, notice that on the left we're going to end up with an x squared. And notice that we have x plus a number. That tells us that we have a vertex that is not the origin. And the x squared tells us that this is going to open up or it's going to open down. Now, we know because this is an x squared and the vertex is not at the origin, that it's going to follow x minus h squared equals 4p times y minus k. So our vertex is going to be the point hk. Our h is found with minus h. Here we have x plus 2, which is the same as x minus -2. So our h value is -2. Our k is the value that gets subtracted from y, so it's 1. So our vertex is the point -2, 1. Our focus is the point h, k plus p. Well, we know h, that's -2, but we don't know p. So we need to find p. 4p is equal to -6 for our equation. So divide by 4. That's funny, this is the same value we got for the one above. P equals -3/2. So here, k plus p of -3/2. And we need to simplify this. And that would be a point of -2, negative 1/2, right? Because we have 1 plus a negative 1/2. Okay. And then our directrix is going to be the equation y equals, because remember this is opening up or down, k minus, that should be a k, minus p. Our k is 1, and we're subtracting our p, which is negative 3/2. So 1 plus 1/2, which is 2/2, or y equals 5/2. Okay, I left this graph here, but we're actually going to graph this one with our graphing calculator. And in order to do that, let me delete this graph. And we need to solve our given equation in terms of y, right? Because our graphing calculator can only graph y equals. So we need to slowly isolate this y. First, we're going to divide by negative 6. That removes the negative 6 on the right and leaves y minus 1. And on the left, we have x plus 2 squared divided by negative 6. Do not worry about how messy and ugly this is going to look, because the calculator is going to deal with it, not us. Last step in isolating y, let's add 1 to both sides. This is going to give us the equation y equals x plus 2 squared divided by negative 6 plus 1. Super ugly, but we don't care. We're going to plug this into our graphing calculator. So go to your y equals, and we want to use a lot of parentheses. So one set of parentheses to give us a numerator, and the second to put in that squared. So we have x plus 2, close the parentheses, and we need to square that. Then we're going to close the parentheses because this is our whole numerator, and we're going to divide by negative. Remember the negative sign, not the minus, 6. And then we're going to add 1 and hit enter. Let's hit graph and see there's the graph of our parabola. It opens down, which we expected because our p was negative, right? It's negative 6 for our 4p. And we guesstimated our vertex at negative 2, 1. That would be about here. That looks correct. So there we have the graph of this parabola. Now, what if you're told some characteristics of a parabola and you need to come up with the equation for that parabola? Well, we have 2 examples. First, we have a vertex of 0, 0, and we have a focus of negative 3, 0. Well, a vertex of 0, 0, that means we're going to have the basic x squared equals or y squared equals. Now, the way we determine which one is based on the focus. The focus here is P0. Because our P value is in the x coordinate spot, I like to think that my P is with x, which tells me I have the equation y squared equals 4px. My P is with my x. Now I can substitute in what I know. I know the P, so I have y squared equals 4 times my P of negative 3, x. Simplify, y squared equals negative 12x. Okay, example 2. We're given some different things. The focus and the directrix is x equals negative 7. Well, the focus, the P is first, so that tells us we're going to have a y squared again, right? Because the P is with the x. Now the directrix is x equals, which also tells us we're going to have a y squared, and it's negative p, right? Our p here is 7, and this works out that x equals negative p. We know that our vertex is going to be the point 0, 0. Ooh, my pen's not happy. So our vertex is at the origin. So our parabola is of the format y squared equals 4px. We're going to substitute in the value of p, which is 7. My pen's being all kinds of goofy. And I get y squared equals 28x for the equation of this parabola. Okay, lots of information on that first page for you to review and start being able to recognize. I don't think you really need to memorize everything about the parabolas, but at least be able to quickly reference and recognize what type of parabola you have. Any questions or a problem you need help with, please reach out. Leave it in the comments, email me. I'm happy to help you.